we can check our general solution with the curve that we sketched to approximate the function. First, we project this curve back or extend this curve back a little bit in the direction of the y-axis so that we get the y-intercept. The y-intercept here is approximately, let's estimate this, maybe about 0.3. Well, if when t equals 0, this function is equal to 0.3, then we know that our solution should be y of t equals t squared over 4 plus 0.3. We know this, and there's a formal way to write this out, but we know this simply because if t equals 0 and y of t is 0.3, if y of 0 equals 0.3 in other words, then, well, when t is 0, t squared over 4 doesn't contribute anything, and we have to have 0.3. So we conclude that this function should be one of our solution functions. Now let's see if this function y of t, and I just messed up my my writing here, but y of t equals t squared over 4 plus 0.3 is going to be a parabola. It's going to have y-intercept 0, and it's going to have an upward curvature. And when y gets to the value, or I'm sorry, when t reaches the value 2, then y of t should be 2 squared over 4 plus 0.3. That's 1.3, which means that the curve should ideally go through the point 2, 1.3. The curve that we sketched doesn't miss this point by much. It means we did a fairly good job of sketching an approximate curve, but now we know exactly where that curve should have been if we accept our estimate of the y-intercept as 0.3. Of course, this depends on that estimate.